Welcome to Lesson 12, Ratios of Fractions and Their Unit Rates. Continuing to look at fractions and creating unit rates, and also a few other things will be entering the fray. Some geometric concepts that you've learned in the past, area, perimeter, and things of that nature. So get ready for this. With this lesson, this first part of the lesson, the quote-unquote classwork portion, is a project of sorts, and it is intended that you do it yourself and then also brainstorm with a partner in the class. We will not at this time do that partnering, because you'll be doing this at home. But again, use your parent teacher or a sibling or a friend as a partner. Hopefully some of you are getting together with friends to do some math at some times. But anyway, yeah, so I'm going to go ahead and read this to you, and then I want you to spend some time making a plan, and then we'll come back and we'll talk, and then we will talk some more later on and see how you solve this problem. Okay, so during this lesson you are remodeling a room in your house, at your house, okay, a room in your house, and need to figure out if you have enough money. You will work individually and with a partner to make a plan of what is needed to solve the problem. After your plan is complete, then you will solve the problem, determining if you have enough money or if you are short money. Okay, so here it is. Example 1, time to remodel. You have decided to remodel your bathroom and put tile on the floor. The bathroom is in the shape of a rectangle, and the floor measures 14 feet 8 inches long by 5 feet 6 inches wide. The tile you want to use costs $5 each, and each tile covers 4 2/3 square feet. If you have $100 to spend, do you have enough money to complete the project? Now, the first part of this is to actually just make a plan. So do not have to do any calculating at this point. Just make a plan, deciding what you already know, what you need to find out, and how you're going to find it. Okay, so one thing I already know, and I'll just start you off here, are the dimensions of the floor. Okay, so when we're talking about putting tile down or carpet, we are talking a two-dimensional area, okay, of the floor. Dimensions of the floor. 2 dimensions, okay, that's 2D, okay. We know that it is 14 feet 8 inches long, 5 feet 6 inches wide. Okay, so you imagine if we know those dimensions, and then what do I want to find using those dimensions? Okay, and I'm going to help you out here as well right now, so you can get started. We want to find the area. Okay, so we want to find how much space is taken up by this area, okay, this room. This is probably not a very good rectangle, but okay. So the how to find it, I want to see if you can go ahead and do that yourself. There's a couple of, there's a few more things that you know, and I want you to go ahead and what you need to find out from using those things that you know, and then how to find it. Okay? So all I want to know, and again, is how to here. I don't want you to actually find the area. I want you to tell me how you would get that area, okay, most effectively. So go ahead and work on that for a while. It could take some time. Take whatever time you need. Come on back when you're done. Okay. Okay, welcome back, and let's go ahead and note a few more things that we know. We figured out we knew the dimensions of the floor. We knew that we wanted to find area using those dimensions. Okay. Something else that we know is we know how large, or how many square feet each one of these tiles is. Okay, so we know the square foot, the square feet of one tile. Okay. All right, and what we want to find out using this here and then this here, what this is going to help us do is it's going to help us figure out or calculate the number of tiles needed. Okay, the number of tiles needed to cover what we had. Okay, we also know, something else we know is we know the cost of one tile. Okay, and that's $5 each. Okay, so we also know the cost of one tile. And then with that information, we can find the total cost. Total cost to cover floor. All right. And one last thing we know is that we have a limited budget and we have $100 to complete. Okay? We have $100 to complete the project. I have $100. Okay? And what we'll find out using that is, do we have enough? Let's see, came from. Yes, so we have the dimensions of the floor. From that we could figure out the area. We have the square feet of one tile. From that we can figure out the number of tiles needed. We have the cost of one tile. We can then figure out the total cost to cover the floor. So these things are all moving down. One piece of information is leading to the next. Okay, and then we know we have $100, and then we can figure out, do we have enough, comparing the total cost to our $100. Okay, so now hopefully you know, been working with it long enough, how to find area. Okay, we know that area is going to be length times width, right? Okay. Now with our with this area, we have the dimensions that we have. We have 14 feet 8 inches, 5 feet 6 inches. So we have 14. That's how you make feet 8 inches times. So again, there's a 5 feet 6 inches. 5 feet 6 inches. And as we are talking about fractions and their unit rates, let's do some conversion. And if we convert our feet and inches into a fractional feet and inches, we know that's 14 and 8/12 times 5 and 1/2. Okay, again, you know that 6 out of 12 is 6 inches, so 6 over 12 is the same as 1/2. Okay, so now if we do this, we can do that multiplication, okay, and we can figure out our total area. Okay. Now that total area, the way to find our number of tiles needed here is to go ahead and take area and divide by the area of one tile. Okay, and that information we have right over here. We have the area of one tile right there, and if we take the total area, I should put total here, take total area, which we will get from this, and then we divide it by the square feet of one tile. Okay. Now to get total cost, we are going to take those total tiles needed, and multiply by cost of one tile, which we know to be $5. Okay. All right. And now all we have to do here is, at the end here, do we have enough to answer that question? We're just going to compare total cost to $100. Then we'll know yes or no if we have enough. Okay, so the next part of this this project would be, if we were in a classroom right now, we would compare each other's plans with a partner, and then using the plans together, we would determine how much money we would need to complete the project, and also to figure out if we had enough money or not. So, in lieu of that, we are going to do this together. So I am going to be your partner, and what I'll do is I will go over this together with you. Have a nice big piece of paper, you know, that graph paper that I gave you, that pad. Let's fill that in if you need to actually do some figuring. Okay, and you get ready for that, and I'll be back, and we'll do that together. Okay, so let's work this out together, and we'll use our plan here. First step is to find the area. Find the area of this room with the dimensions that we've been given. Okay, and that's this part right here we're going to work with right now. Okay, so we already converted our feet and inches into fractional feet. So instead of 14 feet 8 inches, we have 14 and 8/12 feet. See how that is different? We've kind of taken the inches out of it and created a fractional portion of a foot. Okay, so we need 14 and 8/12, and again, some of you are probably looking already, knowing that we can reduce some of these or simplify, times 5½. Okay, so now what we've done is we've made this feet times feet, which is nice because we have feet times feet instead of feet and inches times feet and inches. We have a unit, a common unit, which will help us when we get our final answer. Now we go ahead and conduct things like we did in the prior lesson. Okay, so first let's go ahead and reduce that 14 and 8/12, and that would be 14 and let's see, 2/3, right? Because we have a greatest common factor of 4, and then 8 divided by 4 equals 2, and then 12 divided by 4 equals 3. Okay, so now we have 14 and 2/3. So we have 14 and 2/3 times 5½ which is as simplified as we can get. Okay, and you remember now we talked about last time is making these into improper fractions, which are much easier to deal with when it comes to multiplying fractions. Okay, and if we do that, we have to find out how many thirds there are in 14 wholes. and that's 14 times 3. And again, I'm doing this again and again. I want you to be able to do this by yourself without me modeling it, but I'll continue to model it until I feel people have this under control. So that's 42 thirds plus another 2 thirds. So that's 44 thirds times 5½ converted into an improper fraction. Of course, there are 10 halves and 5 wholes, and then add another 1. That's 11. So there we go. We have now this is multiplication. So it's not like last time where we had division and we were using a reciprocal to do multiplication. We have our multiplication, and plain and simple, this is what it's going to be. Before we do that, again, to make things more a little bit neater, is let's go ahead and cross divide where we can. These have a common factor here, 2 and 44, and they are 2, so this would become 1. This would become 22. Okay, so now we have 22 over 3 times 11 over 1, and if we did this multiplication, 22 times 11, I'm going to just show you how I would do it. I would do it 22 times 10, which is 220, and then 22 times 1, which is 22, 242, so 242 over 3. And then if I did that, so here we go, we have our final fraction here. And again, now we need to turn that back into a mixed number. And to do that, we ask ourselves how many 3's, of course, are in this 243. And that would be 80 and 242. 80 and 2 thirds. Because 242 divided by 3 is 80. And then we have the 2 left over, which is another 2 thirds. Okay, so 80 and 2 thirds feet. This is our area. So we could go back here, and let's just go ahead and put that right in here, and have a purple. Okay, 80 and 2 thirds feet. That is our area. We have step number 1 done. Okay, so our next step, now that we have our area, that's the first thing we needed to do, because we used that what we knew, which were the dimensions of the floor. We took that and we converted our feet and inches to straight fractional feet, and we got 80 and 2 thirds feet. Now the next thing we knew we had the square feet, or the area of 1 tile. Okay, and that was going to give us the number of tiles needed. And what we needed to do is we needed to take that's our plan here. Remember, take the total area, which was 80 and 2 thirds, and divide by the area of 1 tile. Okay, so now we have 80 and 2 thirds divided by the area of 1 tile, which was, I've forgotten here, is 4 and 2 thirds square feet. Okay, so we need 4 and 2 thirds. So we have, let's erase all this. We've done all that. We have 80 and 2 thirds feet, right? Divided by 4 and 2 thirds. Actually, this is feet squared. We've got to remember that now. Did I write that over here? We should know. This should be squared. Remember, always have to have error. I'm so sorry, I forgot that. That is a big no-no. Okay, 80 and 2 thirds feet squared. Very, very important. I forgot my unit. I'm so sorry. But so 80 and 2 thirds square feet divided by 4 and 2 thirds square feet. Okay. All right. So we need to do that division. Now, if you remember, hopefully you recall, in lesson 11, we did quite a bit of this. First step is go ahead, let's convert into improper fractions. Okay, improper fractions. So this is, again, we know this because we just did this. We just changed it. So we need 242. We're going to divide that by, this is 14 over 3, and hopefully you can see where I'm getting that from. Okay, you can see that right here. I just went 4 times 3 was 12, plus another 2 is 14 thirds. Okay, This we can drop out right now. We don't really need to worry about that because if we're dividing square feet by square feet, we're going to come up with a single number. And again, if we have thirds divided by thirds, and if you remember in the past, all we need to do is be concerned with just need to be concerned with the numerators. In this case, we have 242, and we're going to divide that by 14. All right, and I'll do this right in front of you. 14, 102. Let's see. Oh, it looks like an even number, doesn't it? No, it doesn't. I thought it was going to be 8, but it's not 8. So it's going to have to be 7. 17. That's 8. 2, 98. 4 and 40. So 17.3, just about 3. So 17.3 tiles. Now that's an interesting number. Would anybody suspect that we would round down to 17 tiles? And why might that not be a good idea? Okay, very, very important point here. We're trying to figure out how many tiles we need to purchase, and if we come up with an answer of 17.3 tiles, and the way we got this again was taking our total square footage, okay, and dividing it by the square feet of one single tile right here to get this number here, 17.3. We have to remember when we're doing problems like this, if there's any fractional portion, when you're talking about laying down a tile, putting down a carpet, painting, you need to round up in this case, okay, because 17 tiles is not going to do it. I'm still going to have 0.3 tiles worth of floor that has no tile on it. So we're going to need actually 18 tiles. Okay, we're going to need to purchase 18 tiles to cover this floor. So let's go ahead and put that in here. So now we have 18 tiles. Okay, now our next bit of information is we knew the cost of one tile, and that cost of one tile was $5. Okay. Now from that we can find out the total cost to cover the floor because we can just multiply our $5 per tile times the 18 tiles we need to purchase. Erase all that. 18 tiles times the 5. Okay, and we have $90. Okay, so our total cost is going to be $90. This is looking good, huh? Yeah, so if our total cost is $90 for these 18 tiles, which will cover this 80 2/3 square foot of room or floor, that is a good thing because we know that we have $100. Do we have enough? And the way we figure that out is to compare our total cost, which is $90, to the $100 that we have, and our answer to that question would be a resounding yes, we have enough. $10 left, we can splurge on something. So, yeah, so again, this is the kind of problem that you're going to encounter very often in your algebra career going forward from here. Main piece of advice is to always make a plan. It's something that has so much, it's just information packed. You have the dimensions of the room, you have the cost of a tile, you have the area of each tile, you have your money that you have to spend. All of that needs to be put together into a plan. And again, tables are a wonderful way to do that, like here. Decide what you know, what you will find out using what you know, and then how you're going to find that out. Okay? Yes, we will come across these several times this year. Okay, so we have one exercise to complete. Again, a multi-step exercise to complete before you get into your problem set and your exit ticket. Okay, and I'll read this to you. It's a practical exercise for people like such as myself and your parents who are who are driving and own vehicles. This may be a little bit hard to understand for you, but if we can talk more about it. And when I come back to help you guys solve, we'll talk a little bit more of it at length. But anyway, here is the exercise. So, which car can travel further on 1 gallon of gas? Which car can travel further on 1 gallon of gas? Here we go. We've got a blue car. Let's use a blue pen here. A blue car travels 18 2/5 miles using 8/10 of a gallon of gas. And you notice how tricky they are now using decimal notation. But again, remember, every decimal can be made into a fraction. Okay, 8/10 of a gallon of gas. Really silly. I'm not sure exactly why you would use all these convoluted numbers, but we're just trying to get you to use what you know here. And the red car with a red pen travels 17 2/5 miles using 75 hundredths or 3/4 gallons of gas. Okay, so go ahead and pause and come to a conclusion to which car can travel further on 1 gallon of gas. Remember this, 1 gallon of gas. Okay? Okay, I'm going to use my table to just to work this one out a little bit, just to set it up. Actually, as more or less a plan of sorts. So the gallons. Now I'm going to do my red car first. The gallons of gas is 8, and I'm going directly to fractions here. So I'm converting these decimals into fractions. So I have 8/10 gallons right here, and I'm sorry, that's not red. Erase that. So sorry. We have actually 75 over 100. Okay, or 75 hundredths. I'm going to convert that or simplify that right away because I know 75 out of 100, like 75 cents out of $1, okay, is 3/4. 3/4, okay? So I have 3/4 gallons, and the miles I go are 17 2/5 miles, okay? And now my blue car, again laying it out here. Now we have our 8/10. I'm going to go ahead, since I've simplified the red car, I'm going to go ahead and simplify this one. I know there's a common factor here, which is 2 is our greatest common factor, and that's 4/5. Again, is equivalent to 8/10, but is in its most simplified form. And we have here is 18 2/5 miles. It goes. Okay. All right. Now this last column, of course, is always our unit rate or our constant proportionality, as you remember. And in this case, it's a very, very familiar one to drivers all over. Well, drivers in this country anyway, since we do use miles and gallons. But it's miles per gallon. Miles per gallon, MPG. And that is a unit rate. And the unit it is looking at is going to be gallons. Okay, gallons is the unit. We want to find out for every gallon of gas how many miles we can travel. Okay, and that's what we're going to calculate. Okay, so I have my whiteboard here, and I'm going to go ahead and calculate the unit rate, the miles per gallon for my red car and my blue car. We'll start with red. Go get those numbers again. And again, if we're thinking of this table in terms of x and y, we know we are dividing y by x, so we need 17 2/5 over 3/4. Okay, because we're going to get miles per gallon. Miles per gallon. Okay. So, and again, we've been doing this quite a bit now. Hopefully, this is coming more and more natural to you. You have a complex fraction here. We are dividing, and first what we need to do is let's go ahead and change this, change our mixed number in our numerator to an improper fraction, and that's 17 times 5 is 85, plus another 2 is 87, so that's 87 fifths over 3/4, which don't reduce. We've reduced those already. Okay, and now we know if we're dividing 87 fifths divided by 3/4, we can turn that into a multiplication problem using the reciprocal, which is 87 fifths times 4/3, and again, this is our reciprocal of our denominator here. Okay, and we can go ahead and we're looking here. We don't have 4 and 5. There's no common factor there. 87 and 3. 87 and 3 have a common factor. How do I know that? Well, let's talk about that just for a second. If you know the trick, and here is the trick, and I love this. If you take any number and you add its digits, so in this case its digits are 8 and 7. If I add 8 and 7, I get 15. Any number that comes out that is divisible by 3, and that is 15 here, by adding its digits, this 87's digits here, okay? If that result is divisible by 3, then this number, whose digits I use, is also divisible by 3. So I can look at that and I'm seeing the 7. I know there's got to be a 9 over here. Okay, so I know that, well, let's just do it. 87, that's 2, and it's going to be 29. Okay, so 29. So actually I can go ahead and cross divide here. Now this is 29. And this is 1. And the reason we do this is just to make it more simple in the end. You do not have to do this at all. I mean, this answer is going to be the same, but just makes life a bit easier. So again, multiplying across 29 times 4, what is that? That's 6 and 3, 116 over 5. 116 fifths. Okay, and again, that's 116 fifths miles per gallon, and again we have to turn this improper fraction into a mixed number again, and if we did that over here, 116 divided by 5, that's 20, 16, that's 23 and 1/5 miles per gallon. 23 and 1/5 miles per gallon. And again, you saw here when I'm working with fractions, I am just taking that final leftover, that final remainder, and just putting it over, using it as my numerator and using my my divisor here as my denominator. Okay, so the red car, 23 and 1/5 mpg. Okay, right there. All right. Now I'm going to go ahead and just clean up this mess here, because this is really a mess. And if you need to have that explained again, you can just back this thing up and you can just watch it again. Hopefully you are doing that sometimes, as monotonous as my voice must be getting. Okay, so here we go. Let's do the blue car. Blue car, let's find our numbers we need, our data, 18 and 2/5 over, we figured 8, 10, what did we do? We turned that into 2/5, didn't we? No, 18 2/5, I'm sorry, we turned that into 4/5 here. Okay, over 4/5. Working like we did up top there, we're changing this mixed number into an improper fraction, and that would be 92 over 5 divided by 4 over 5. Ooh, this looks a little neater. We love seeing this. When we have these common denominators here, we love it because life just gets so much easier. we can just put 92 fifths divided by 4 fifths here. We don't really need to worry about the reciprocal here, though you can do it. I mean, this is correct. This is also correct to do. Okay, I mean, sorry, you could. This is correct, absolutely. But remember what I told you: when you're dividing fractions that have similar denominators, all you need to do is just divide those numerators. And if we divide 92 by 4, we get 2, and we get 8, and we get 12, and we get 23 miles per gallon. Okay, here we go. We got the blue car. 23 miles per gallon. That means every 23 miles you drive uses a gallon of gas. Red car. Every gallon of gas you use to get you 23 1/5 miles. So, if we go back to our original question, which car can travel farther on 1 gallon of gas? Which would be your answer? And yes, if you chose the red car, you are correct, because with 1 gallon of gas, you can get a whole 1/5 of a mile farther than the blue car. Not significant, but farther nonetheless. Okie doke. Okay, so hopefully this is getting easier and easier, or more and more understandable. I know it's not going to be easy at first, because this is all very messy looking stuff. Complex fractions this is something that many of you are dealing with for the first time only. And it is strange, because no one ever told you when you were younger that you could have something that even looked like this and it to be real. Okay, that would be just, oh, you can't do that, is probably what we would have said when you were in 1st, 2nd, 3rd, 4th, 5th grade. But no, you can do this, and you do this. Okay, it takes time, but honestly, I know many children who end up thinking this type of algebra is a lot of fun, and hopefully it can become more and more fun for you. So the rest of this lesson is just going to be you sitting down, doing your problem sets. Space them out. I know sometimes these are very lengthy problems. If they're taking you too long, I don't want you doing over 2 hours of math a day and just getting burnt out. But to be realistic, somebody in a regular campus school is doing just that, has an hour of math and has at least an hour of math for homework. So 2 hours of math is not unusual, but beyond that, we don't want you to burn out. So if the problem sets become too lengthy, maybe you do one less problem. Okay, well, good luck with the problem sets, good luck with the exit ticket, and I'll see you in lesson 13.